Today I got some LEDs. I will glow this LED with different level of voltage sources. So here I have 3 volt, I have 6 volt and 9 volt battery. Different color of LEDs have different forward voltage. You can see in the table. The forward current for LEDs is nearly 20 milliampere for all the colors. So if we use the source voltage is more than the forward voltage, we should use a resistor to protect our LED. Let's draw a simple circuit to calculate the resistor value. Here the source voltage Vs. Then we are adding a resistor. We will calculate this value of resistor. Here is a LED which is connected in a series with resistor. Let's consider the forward current for this LED is IF. And the forward voltage is Vf. From Ohm's law, we can calculate the resistor value, which is R equal to source voltage minus forward voltage divided by forward current. Let's say we will use 3 volt as a source voltage. For calculating R, let's put the source voltage 3 volt. For forward voltage of LED, we should check the data sheet. Let's consider this is a red LED. Here is the red LED. We can find the forward voltage and forward current for this LED from the data sheet. So from the data sheet, we know the forward voltage for red LED is 2 volt and the forward current is 20 milliampere, which is 0.02 ampere. So replacing forward voltage with 2 volt and forward current with 0.2 ampere. Let's calculate the value. 3 volt minus 2 volt, which is 1 volt divided by 0.2 ampere. So the result is 50 ohm. So here the resistor value will be 50 ohm. Let's implement this circuit physically. So here we have 3 volt battery. Here we will use a small breadboard and this is the red color LED. All the resistors look like same, so I will use a multimeter to measure the resistance value. So let's find the accurate value. Here you can see this is 47 ohm, so we can use this 47 ohm instead of 50 ohm. If we don't get exact value of resistor, we'll use the most nearest value. Let's complete the circuit. Here you can see the LED is glowing, so this LED is now safe. So now we will measure the resistance value we need for 6 volt power supply. So everything will be same, just remove here the source voltage 3 volt, so we'll use 6 volt. Here we have to change the resistor value. We'll calculate this value. So before that, let's replace the 3 volt with 6 volt. So here will be 6 volt minus 2 volt, which is 4 volt, and the forward current is remaining same. So after calculation, the value is 200 ohm. Now let's check physically. Here the 6 volt. So let's find the resistor which is near 200. So here you can see 202, so which is nearly same. So I'm connecting this resistor in a series with LED. So if we use 9 volt as a source voltage, let's find the resistor value. The calculation will be same as we did before, just replacing the source voltage with 9 volt. The source voltage will be 9 volt. So let's replace 6 volt with 9 volt. So 9 minus 2 will be 7 volt. The resistor value comes 350 ohm. So let's find the resistor value. I'm using again multimeter. So here I got 327 ohm resistor, which is the nearest resistor I have. Connect in a circuit same like before. So here you can see. Now I will measure the resistance value if I connect two LED in a series. So let's draw the circuit first to calculate the resistor value. Here is the source voltage. So then this is the resistor. We'll calculate this resistor value. Now I will add two LED in a series. Here is the LED 1 and then there will be another LED in a series which is LED 2. As the two LEDs connected in a series, so the same current will flow. So let's assume the current is IF, which is forward current. We know the forward current for LED is 20 milliampere, which is 0.02 ampere. The forward voltage of the circuit will be the summation of two forward voltages of two different LEDs. So let's say for the first LED the forward voltage is VF1 and for the second LED is VF2. So the forward voltage of the circuit will be VF1 plus VF2. So as we are considering the forward voltage is 2 volt, so it will be 2 plus 2, which is 4 volt. So now let's go back to the equation for resistor value, which is source voltage minus forward voltage divided by forward current. So here now we use the source voltage equal to 9 volt. So let's replace the source voltage with 9 volt and the forward voltage with 4 volt, and the forward current is 0.02 ampere. Now if we calculate the value, the resistor value will come 250 ohm. So like before, now I will connect this circuit on a breadboard. Here I got two LEDs, red and yellow. So here I'm connecting these two LEDs in a series. Now I will find the nearest resistor value I have. So here I have 270 ohm, which is close to 250. I have to correct the polarity of the LED. So now it's glowing fine. Now let's calculate the resistor value if two LED is connected in a parallel connection. As usual, first let's draw the circuit so that we can calculate the resistor value. Here is the source voltage, then this is the resistor, then I will connect two LED in a parallel connection. So here is the LED 1 and here is the LED 2. For parallel connection, current will be divided. For first LED, the forward current will be I forward 1 and for the second LED, the forward current will be I forward 2. And the voltage will remain same for the parallel connection. Forward voltage is 2 volt as usual for LED. And now we will calculate the forward current. The forward current will be the sum of two individual forward current. IF1 20 milliampere and IF2 20 milliampere, which is 0.02 and 0.02 ampere. The total forward current is 0.04 ampere. Using the previous equation, which is R equal to source voltage minus forward voltage divided by forward current, Let's consider the source voltage is 9 volt and complete the calculation. From the result, now we know we have to use 170 ohm resistor. So let's implement this circuit on this small breadboard. So I'll connect these two LED in parallel. Then let's find the nearest resistor value. So here I have 200 ohm, which is the nearest value I have. So I can use this. So here's the 9 volt supply. Another important parameter for resistor is power. We have to consider this power also when we will connect the circuit. So what is power of resistors? Here you can see three different sizes of resistor. Let's measure the value of this resistor. At first we will take the smallest resistor we have. So the value of this resistor is 99 ohm. So now let's check the medium one. The value of this medium one is 98 ohm, and the biggest one, this one also 98 ohm. So how is possible all the different sizes of resistor giving the same value? Then what is the difference between them? So the difference between them is power rating. So for the smallest resistor, this is 1/4 of watt, which is 0.25 watts, and the medium one, this is half watt, which is 0.5 watt, and this biggest one, this is 1 watt of resistor. Now we will see which resistor I should use in my circuit. We know the power equation P equal to voltage multiplied by current. Let's draw a circuit like before to better understand. Here is a circuit, the source voltage is 9 volt, and here is the resistor. We will calculate this resistor value, and there is the LED. So for calculating the resistor value, we need the forward voltage, which is V forward, and the forward current is I forward. So from previously we have learned how we can calculate the value of resistor. So the equation was R equal to source voltage minus forward voltage divided by forward current. Here this is called voltage drop, the difference between source voltage and the forward voltage. If we put the value of source voltage and forward voltage in the equation, we will get the result is drop voltage divided by forward current. So here 9 minus 2 equal to 7 volt, which is the drop voltage. From the equation we know the resistor value. So here the voltage drop is 7 volt divided by the forward current, which gives the resistor value is 350 ohm. And what will be the power? So the power will be the voltage drop multiplied by the forward current. So the voltage drop is here 7 volt and the forward current is 0.02 ampere. So the result comes 0.14 watt. So we can use 0.25 watt resistor as our power is less than 0.25. Let's check another example to make this concept clear. So now we will change the source voltage. We will increase the source voltage and we will take the source voltage, for example 24 volt. Let's calculate for 24 volt which resistor we should use. So the same equation, power equal to voltage drop multiple by forward current. Now the voltage drop will be the difference between source voltage and the forward voltage, which is 22 volt, and the forward current will remain same. And the result comes 0.44 watt. So we should use 0.5 watt resistor to make our circuit safe. There have many type of resistor in the market with different watt rating. For example, 2 watt, 5 watt, 10 watt, 20 watt, etc. So whenever we will choose any resistor for our circuit, we have to consider two parameters. The first thing, the resistor value, and the second thing, the power rating of the resistor. Before end this video, can you tell me which resistor should I use for this circuit? Also mention the power rating of the resistor. Have a good day.